So next topic we will see about power modes. So STM32 have several low power modes which are available to save the power consumption of the CPU, especially when the CPU does not need to be kept running. For example, when waiting for an external event. So CPU enters sleep mode, and we have the WFI and WFE. There are two different ways. It's based on the internal or external event line. So event means here we can take it as an interrupt. And also we have the sleep mode, one pan and sleep deep. So it's same like our laptop or our computers. In our computer also we have the sleep mode and the screensaver and so on, right? So why we have the sleep mode? It's just like if you are not using the computer for quite some time, it will automatically go to the sleep mode to save the power. And even your mobile phone have the same. So here also we have the power modes in microcontrollers for similar purposes to achieve the low power. So low power mode reduces the amount of juice your device needs. So it's not quite running on all cylinders. Okay, so we have actually, if you can look at the reference manual, you can see this sleep on next and sleep on pend and sleep deep. So it's just a temporary sleeping mode, or it's really going to be a deep sleep or something like that. So you have the options. And for example, the sleep mode code snap experiment results are below. So we can enter the sleep mode by configuring all GPIOs as analog and disabling the GPIOs clocks. So GPIO means that is the input output pins. So you can configure them everything into analog mode, and disabling the clock signal that will also help you to bring the microcontroller into the sleeping mode. And exiting from sleeping mode is an EXTI, external interrupt push button is mapped into EXTI pin. So we are giving this signal. It means so that we are giving the disturb signal, interrupt signal externally. Then immediately the microcontroller will resume back. It will come back to the active mode. So typical maximum and minimum current consumption or maximum current consumption during the sleeping mode. So it's given here. It's available in the table. So here you can see the sleeping mode. The power consumption is much lesser. This is just a room temperature, 25 degree. The normal mode, you can see when all the peripherals are enabled, it's consuming this much of power under the 25 degrees Celsius, 10.2, 7.8 and so on. But at the same time, when we disable all the peripherals, when it goes to the sleep mode, then what's happening? You can see the power consumption is much lesser when compared to the active mode. So instead of having all the peripherals active all the time, so we are just going into the sleeping mode and disabling some peripherals and saving the power. This is another way of saving power practically. So of course, yeah, the current consumption in sleeping mode here, this is one of the lowest power consumption with 8 megahertz, the high-speed clock frequency. So if you want to read more details about the sleep modes, you can go into this reference and you can see what are the different types of analysis they have done and what kind of experiments they have done for this to analyze the low power modes.